This is a Beautiful Mars podcast for Friday, January 27th, 2017, from HIRISE, on board NASA's Mars Reconnaissance Orbiter. A layer of dry ice covers the south polar layer deposits every winter. In the spring, gas created from heating of the dry ice escapes through ruptures in the overlying seasonal ice, entraining material from the ground below. The gas erodes channels in the surface, generally exploiting weaker material. The ground likely started as polygonal patterned ground, common in water ice-rich surfaces, and then escaping gas widened the channels. Fans of dark material are bits of the surface carried onto the top of the seasonal ice layer and deposited in a direction determined by local winds. In this context image is an old, degraded crater that has undergone a complex history of burial and erosion. The image shows a surface with at least two types of exposed bedrock, one that is light-toned and one that is dark. An enhanced color infrared image highlights these two exposures in yellows and blues, with such colors representing altered and unaltered surfaces respectively. The overlying rougher bluish-toned bedrock appears to have undergone the most extensive erosion, revealing the smoother, fractured yellowish-toned bedrock below. We see wind-blown bed forms across the image, possibly the culprit behind the erosive forces that have removed and uncovered the underlying yellowish-toned bedrock visible today. The drainages in this image are part of Hebrus Vallis, an outflow channel system likely formed by catastrophic floods. Individual channels range from several hundred meters to several kilometers wide and form multi-threaded patterns. Separating the channels are streamlined forms whose tails point downstream and indicate the channel flow is to the north. The channels seemingly terminate in an elongated pit that is approximately 1,875 meters long and 1,125 meters wide. Using the shadow that the wall has cast on the floor of the pit, we can estimate that the pit is nearly 500 meters deep. The pit, which formed after the channels, exposes a bouldery layer below the dusty surface mantle and is underlain by sediments. Boulders several meters in diameter litter the slopes down into the pit. Pits such as these are of interest as possible candidate landing sites for human exploration because they might retain subsurface water ice that could be utilized by future long-term human settlements. Ground that has a lot of water ice mixed with dirt tends to crack in polygonal patterns, bounded by short, straight channels. In the south polar region of Mars, this type of terrain may be covered by a seasonal polar cap composed of dry ice. In the spring, as the seasonal cap sublimates, gas is trapped underneath the seasonal ice layer until it can escape to an opening. At this site, faint rectangular channels in the surface are visible. The escaping carbon dioxide gas has exploited these channels, and in the process, deepened them and added sinuosity to the formerly straight segments. You can see these images and more at uahirise.org.